Consider the experiment of tossing a coin. If the coin shows heads, toss it again. But if it shows tails, then throw a die. This means we're running an experiment where we toss a coin first, and based on what we get, we do different things. If we get heads, we toss it again. If we get tails, then we throw a die. Find the conditional probability of the event that the die shows a number greater than 4, given that there is at least one tail. Pause the video, try this out. Okay, let's do this together. Let's first write down our sample space. We have heads in the first toss. If you have heads in the first toss, in the second toss, we'll get either a head or a tail. So the sample points are head, head and head tails. If we get tails in the first toss, then we are not tossing a coin again, then we are rolling a die. And the die will give numbers from 1 to 6. So either we have head, head or head tails, or we have tail and 1, tail and 2, tail and 3, tail and 4, tail and 5 and tail and 6. 6 plus 2, we have 8 sample points. Now good question is, are all of these 8 sample points equally likely? Is the probability for all of them 1 by 8 each? Think about it. Well, the answer is no, they're not all equally likely. Let's try figuring out probabilities for a few of them. Let's look at head and head. Getting a head in the first toss has the probability of 1 by 2. There's a 50% chance. And getting a head again also has a probability of 50%. That's half. So getting 2 heads in a row has a probability of 1 by 4, 25%. So there's a 25% chance that we'll get a head and a head. Similarly, there's a 25% chance that we'll get a head and a tail. 1 by 2 times 1 by 2 is 1 by 4. Now the probability of getting tail in the first toss is 1 by 2. But getting the number 1 when we roll a die is not 1 by 2. That's 1 by 6. All 6 numbers are equally likely. So getting a tail and a 1 is 1 by 2 times 1 by 6. That's 1 by 12. So the probability of tail and a 1 is 1/12. That's the case for all other sample points. Getting a tail and a 5, the probability of that is 1 by 2 times 1 by 6. That's also 1 by 12. So each of these have a probability of 1 by 12. So if we write down probabilities, this is what we have. Head, head has a probability of 1 by 4. Head, tail has a probability of 1 by 4. And all other sample points have a probability of 1 by 12. All right. Now let's look at our events. There is at least one tail. Let's take this as the event F. What are the sample points corresponding to at least one tail? Either we can get a tail in our second toss, or we can get a tail in our first toss. So head, tail comes here, and tail 1 to tail 6, all of these come here. So F has these 6 plus 1, 7 sample points. What about this event? The die shows a number greater than 4. Let's write that down as well. Let's take this as event E. We want a number. This means the first toss has a tail. That's the only case when we can get a number. And we want that number to be greater than 4. So the sample points here are T5 and T6. So this is our event E and this is our event F. Let's figure out E intersection F as well. We get a tail, at least one tail, and we get a number greater than 4. So E intersection F, that's going to be T5 and T6, these two. So what do we need? We need the probability that the die shows a number greater than 4, which means we need E to happen. Given that there is at least one tails, this means F has happened. So we want the probability of E given F. Probability of E given F, that's going to be probability of E intersection F divided by probability of F. So let's figure out the probability of F here. Probability of F is going to be the sum of probabilities of all of these 7 events. Probability of head tails plus probability of tail 1, tail 2, tail 3, tail 4, tail 5 and tail 6. We already have the probabilities for each of them. Let's write them down. Probability of head tail is 1 by 4 and probability of each of these 6 is 1 by 12. So 1 by 4 plus 6 by 12, that's half. This is going to be 3 by 4. So there's a 75% chance that F has happened. Probability of F is 3 by 4. What's the probability for E intersection F? That's going to be probability of T5 plus probability of T6. This is 1 by 12 plus 1 by 12. That's going to be 1 by 6. Now to figure out the probability of E given F, we can use the formula. Probability of E given F, that's equal to probability of E intersection F divided by probability of F. This is going to be 1 by 6 divided by 3 by 12. So 3 comes here, 3 times 3 is 9 and then 2 cancels out. So we'll have 2 by 9 as the probability. So this is what we have. This is the probability that the die shows a number greater than 4 given that there is at least one tail. Let's take one more problem. Consider another experiment of throwing a die. If a multiple of 3 comes up, throw the die again. And if any other number comes up, toss a coin. Find the conditional probability of the event the coin shows a tail, given that at least one die shows a 3. Pause the video, try this out. Okay, let's write down the sample space together. So we're rolling a die first. So we'll have 1, 2, 3, 4, 5, and 6. If a multiple of 3 comes up, that's 3 or 6, then we throw the die again. And if any other number comes up, then we toss a coin. So the sample space looks like this. If 3 shows up, we roll the die again. We have 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6. If 6 shows up, we roll the die again. We have 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. If any other number comes up, then we toss a coin. This means if 1 shows up, then we toss a coin. We can either get 1 heads or 1 tails. Same is the case for 2, 4, and 5. We'll either get 2 heads, 2 tails, 4 heads, 4 tails, 5 heads, and 5 tails. These are all the sample points that we'll get. What are the events? The coin shows a tail. Let's take this as the event E. The coin shows a tail. And at least one die shows a 3. Let's take this as the event F. At least one die shows a 3. Let's write down E and F. So the coin shows a tail. This can only happen if we get something that's not a multiple of 3. This means one of these. So the coin shows a tail. We have 1 tail, 2 tail, 4 tail, and 5 tail. This is E. This can happen when the first die shows a 3. But this can also happen if the first die shows a 6 and the second die shows a 3. 6, 3 also comes here. So this is E and this is F. We want the conditional probability that E has happened given that F has happened. So we want probability of E given F. For that we need probability of E intersection F and we need the probability of F. Let's figure out E intersection F here. So E intersection F is the coin is showing a tail and one of these dice has 3 on it. But this doesn't make sense. If we roll a 3, we're not tossing the coin. If we roll a 3, we'll not get a tails. This means both of these together will never happen. This means E intersection F is phi, or probability of E intersection F is 0. This is good for us. We don't have to calculate the probability of F. We can say that probability of E given F is going to be probability of E intersection F by probability of F, which is 0 by probability of F, which is simply 0. This means the conditional probability that the coin shows a tail, given that at least one die shows a 3, is 0. Or in other words, if at least one of the dice has shown a 3, there is no chance that we're going to see a tail.